And if you know, the answer is yes. If you don't waste your time. So the topic that we're going to talk about are similarity and congruence, and then associations in data, positive and negative associations. So we'll talk about congruence and then we'll talk about associations in data. Arab, I have not taught anything yet, so there cannot be a question, hands down. And remember one thing, this is not a debate class, so we have to be mindful of what we ask versus what we don't. Okay? Alright. So Vishal is also here. I see, I'm just doing a quick check. Everybody is here. So Bhuvan is also here. Very nice. Wonderful. And who is VJT?
Tanu.
Oh, Tanu. Okay. Wonderful. Fine. So let's get started. So as I said, there are two topics that we're going to talk about. One is called similarity and congruence, and second one is associations in data. So what do we know about similarity? Any genuine guesses? Arab, tell me two lines.
Yeah. Is it like they have like similar properties?
Yes. Okay. Dikshita, what is your response? I cannot hear you, Vita. Amoga, what would be your response? What do you mean by similar shapes?
They're like whatever Arab said. They have like similar properties.
Can you guys give me a very practical example of a similar shape, of similar shapes?
They're like the same shape, but they might be different sizes.
Advik is excited to say something. Go ahead.
Like a diamond or a square.
I thought you are going to give me a more accurate answer. Okay, let's see what Dikshita has to say. Dikshita, I cannot hear you. Okay. One last guess. Yes, Agnika. Okay.
Like for example, square and like rectangle, they're similar.
That will be a big mistake. Never say so. Bhuvan.
Like difference in size, but the same shape, but like a different size.
Difference in size, yeah. Bhuvan. One last answer, then I'll give you guys one example that you'll never forget. Yeah, Bhuvan.
Like a square and a rhombus.
No. Similar. When I say similar shapes, I'm talking about only one shape. A square and a square. Rhombus and a rhombus can be similar. Okay. But a square and rhombus cannot be similar. A triangle and an equilateral triangle and a right angle triangle cannot be similar. Okay. It has to be same shape with different sizes. The best example for that is zoom in, zoom out that you do on the phone. Imagine I have let's say a triangle. I search for a triangle here. Let me show you guys real quick. Triangle shape. Come on. Shape. Look at this triangle, okay? When I am zooming in, it's the same triangle. The properties remain the same, meaning the angles will remain the same. The length of the side will only change. It's the same triangle, zooming out, zooming in. It's the same triangle which is becoming smaller, bigger. So basically you will see, this is the most practical example of a similar shape. Any object, any shape, you squeeze or expand without changing its name and properties. Meaning, we are talking about only one property, which is the property of the corners, the angles. If it's a triangle or rectangle, if you zoom in, zoom out, the angles don't change. Yeah? Yeah, Mugar.
I just have a question.
Mm-hmm.
Are we learning about like scale factors today?
Not scale factors. So as I mentioned, there are two topics that we want to talk about. One is similarity and congruence, and second topic is I forgot the name of the topic. Come on.
It's like positive and negative something. Data and analysis.
Associations in data. So don't waste time doing guesswork. Be accurate. So associations in data. That's why I was not taking you guys to places telling you roundabout answer, right? It's associations, okay? So associations in data meaning when you have multiple data to talk about, how do you associate them? How do you look at different flavors of it? The positive and negative associations, that's what we'll talk about, okay? Amoga, does that answer your question?
Yeah.
Okay, all right. So, and let me repeat one more time. I have given you guys the opportunity to let me know a day or two in advance if you want a particular topic to be taught on a weekend. And nobody bothers to send me the message through their parents. That is why I have the luxury of choosing my own topic. I mean, it's not that I want to bother you guys. I pick up a topic which I believe is not taught in the class so far, okay, from the syllabus. But if you want any particular topic to be picked up ahead of time, you have to send me a WhatsApp. Saying that in class will not help because I will forget. Only way to register your request would be by sending me a WhatsApp, okay? Alright? Alright. So, we are talking about similarity. So, when you talk about similarity, you are talking about two shapes being similar only if their some properties are same, and that property is only the angles, only the corners are the same. When you zoom out, meaning you are making this small. When you zoom in, you are making this big. See, between these three triangles, what you see is the angles are not changing. The angles are remaining the same. This angle, this angle, this angle are same. This angle, and this angle are same. What is changing is the sides. They are shrinking or expanding. They are becoming bigger or smaller. Okay? So that is what is meant by similarity. Yeah, Raf.
Are we so like to figure out the similarity? Are we supposed to look at the physical property of the two shapes and find the difference out?
No. So similarity, see, this is again, we are trying to understand what do you mean by similar, okay? So once we understand this concept, then we'll talk about where do we use it, okay? So first of all the time that we are spending is primarily to understand what do we mean by similar. By me talking about it for last 15 minutes, what is that I'm trying to ensure here is that there is no confusion about what is after today's class. If I hear that a rectangle and a square can be similar, then that's a bigger problem for me. Okay? So I'm just trying to make sure that everybody in this class comes to an agreement that, okay, when we talk about similarity, we are talking about same shape, meaning same name of the shape. If I'm talking about a square, I'm talking about a square. If I'm talking about a scalene triangle, I'm talking about scalene triangle. If I'm talking about a rectangle, I'm talking about rectangle only. And within rectangles or among rectangles, when we say two rectangles are similar, what does it mean? We talk about zoom in, zoom out. Meaning, my corner angles remain the same. So my overall look of the shape remains the same. It just becomes bigger or smaller. Have you ever zoomed in a circle to make it a square? Or zoomed out? Can you ever do that? If that is happening on the phone, replace that phone immediately. Yeah? If you are zooming in, zooming out a circle and that becomes a square, throw that phone. That's what it means. And that's what is meant by similar. Yep, Advik.
And I'm guessing the phone's an iPhone 1.
No, it could be a Chinese phone as well. I know one guy who bought an iPad way back in 2012 when I was in China actually, and he bought an iPad from local market. The highest version of the iPad had 64 GB of storage, and this guy bought an iPad, so-called an Apple iPad, which had 256 GB of storage. Apple itself had not released that version, but this guy still could buy one, and he could store only one song in that iPad for the rest of his life. So I'm saying if you are dealing with that kind of a device, throw it immediately. If ever zooming in a circle or a square, convert that shape to a triangle or a rectangle or rhombus, there is a problem with the device. Zoom in, zoom out will make sure that your angles don't change. If you zoom in a circle, it becomes bigger. If you zoom in further, it becomes further bigger. Zoom out, becomes smaller. Okay? But circle remains circle. So what I'm trying to enforce or emphasize on is that if you are doing if you're talking about similar shapes, you're talking about shapes with the same name. Same name, okay? Rectangle versus rectangle. Square versus square. Rhombus versus rhombus. Okay? And then you all can relate it very well. It's nothing but the zoom in, zoom out property that you see on your phones. Yep. Somebody's trying to say something. Yeah, Rav.
So for the circle, I have like a question. So if it's like zooming in or out, it's like that the circle, the radius or the circumference are different when you even decrease them, and they have no angle. So how will that make like a characteristic?
So again, I repeat myself. I'm a very simple guy. I want you all to be simple. Okay? Don't say a lot of things to make things look complicated. Did I talk about circumference? No. Did I talk about radius? No. I only said I have a circle. When I zoom out, it becomes small. When I zoom in, it becomes big. Okay? So let's keep it there, because right now our focus is on understanding the concept. Now you all know the perimeter. You all know what is the property of a radius. When I'm saying zooming in makes it big, what is meant by making it big? Obviously your circumference is becoming big. Your radius is becoming big. But if while teaching concepts, if I try complicating things and if I make it complicated for you guys by using those jargons for no reason, no legitimate reason, okay? Saying when you're talking about similar circles, your circumference becomes bigger, your radius becomes big. I'm saying no. Think about a toddler, 2-year-old toddler. When he or she tries zooming in, this becomes big. Zooming out becomes small. And then we will apply intelligence on the top of that based on what we know to use that in future. So far, we have not used any of the properties. I'm just telling you what happens conceptually. Yes, Dikshita.
So for the circle, we can only zoom out and zoom in. There are no angles for the circle, right? So what is the similarity for circle?
So similarity means your circle became smaller or bigger. That's it. Do you have an isosceles circle or scalene circle? No. You have an equilateral circle? No. Circle is a circle. It's a round thing which has only one property, that is radius. So when you are zooming in, zooming out, only that thing is changing. When you are talking about let's say a triangle, it's an equilateral triangle. Earlier the angles were all 60 degree and the sides were 2 centimeter each. When I zoomed in, 2 centimeter side became 5 centimeter or 20 centimeter, 25 centimeter. So by this side changes. Here, what is the other property that you can change? Nothing. Only radius, right? So circle will remain circle. That's what I'm trying to emphasize. Yeah, Advik, one last question. I don't think there is any merit in the question that you guys are asking right now, but still I'll take it. Yeah.
It's not a question, but can I say an example about it? About the similarity thing?
One more. Yep.
So you know, like when people are babies, they have like the shape thing where you're supposed to like hit it and it goes in.
Mm-hmm.
Like this, the circle one, the cylinder one wouldn't go in the square one. You have to hit it where the square one goes, and then it'll go inside.
Yeah, correct. So that's another example. Yeah. So now let's come back to what is the use. So one thing is called similarity, and second property that I have put in the topic was congruence. So similarity we saw in case of a circle like this. When I talk about congruence, if I say that there are two circles congruent or two triangles congruent, what does it mean? Congruence means exactly same. Exactly same. Meaning each and every property matches. In case of triangle, if I say they are congruent, meaning the angles are same, sides are same. They are matching. I can literally overlay one over the other one or vice versa. But in case of similar, they cannot overlay each other. Okay? So now if you go back to the basic of English, same and similar. Congruence is same. Similar is not same. Yeah? So that's how I would want you guys to relate. So when you talk about similarity, you're talking about the shape being the same, size changing big or small. Yeah.
Isn't similarity like same?
No, never. Similar. Okay? If, let's say, let's look at a practical scenario, okay? If I say, do I look like my neighbor? Let's say if my neighbor is very much like me, he'll say, yeah, you look similar, but not exactly the same. Yeah? So that similar creates a doubt. Same has zero doubt. Yeah? Yeah, everyone.
Wait, sir. So if I draw a triangle and I measure like the angles and I get like three different angles, and I make like a new triangle which is like bigger, but it gets like the same angles, will they be like similar?
That is exactly what will be similar. If you have two triangles with matching angles, that is nothing but zoom in, zoom out. These are two triangles. This is a smaller one, this is a bigger one, but the angles are same. Here you are zooming out, zooming in. When you zoom in, it becomes bigger, but the angle remains the same. So that's similarity. So now let's look at the mathematical part of it. So far we talked about what is similar, what is same or congruent. When you say congruent, you're saying exactly the same. If I'm talking about something being congruent, you're talking about a mirror image of the first thing. Okay? There is no doubt. Each and every property is matching. Okay? And when you say it's congruent or same, there is no doubt. Arab, you have exhausted your quota of asking questions, at least for this topic, so hold it there. Because we have to move on. We cannot just keep talking about similar and same for next 1 hour. Yep. So except Arab, Advik, Dikshita, anybody has any question? Anybody? No questions? Lakshita, any question, beta? No questions?
No.
No? Vishal, Vasundhara?
No.
No? Okay. Alright. So we looked at the fun part of it without looking at the mathematical side of it. Now let's look at some mathematics around it. I have one scenario of congruence. I am saying this triangle A and this triangle B, this is ABC and DEF are congruent. Okay? And then I have second triangle PQR, second pair of triangle PQR and STU. This is congruent and this is similar. People who are not talking, they can go on mute. Okay. So this combination of triangles are congruent, And this combination of triangles are, I'm saying, similar. Now let's look at the mathematical side of it. What happens between AB and DE? I'm saying they are congruent, meaning AB equal to DE. Yeah? I will say this side and this side are same. AC equal to DF. I will say BC equal to EF. So again, Vivaan, you might want to mute yourself better because there is some background noise. Yeah. So between congruent and similar, see, there is one thing common, okay? The angles are matching. Angles have to match, no question about it. So here this angle same, this angle same, this angle same. Angles are same. In case of congruent also, angles are matching. What doesn't match is the sides. I'm taking the triangles example, okay? So I have one situation where I have two triangles as congruent and I have two triangles as similar. When they are congruent, sides are equal to each other. So this side is equal to this side is equal to this side, and this side equal to this side. In this case, that is not the case. Do you know what happens mathematically here when they are similar? Now I want people to talk. Everybody is quiet. You are upside down. Arav, you are upside down.
I think I did something wrong with it.
Huh? Okay, forget about that. That doesn't matter. I can still hear you. Tell me, when they are similar, what happens to this? Here in this case, I said this side equal to this side equal to this side equal to this side. What happens when the triangles are similar? Arav, quick. Just tell me the answer.
What happened again?
Huh?
Can you say the question again?
No, you mute yourself. If you did not hear the question, raise the hand. You'll not get the opportunity to answer. Hands down. Advik.
They're not similar because
No, tell me mathematically. Here I said they are congruent, so this will be equal to this. This will be equal to this, and this will be equal to this. So I put that mathematically. I'm saying in this case, if they are similar, what will be the mathematical formula?
None of them would be equal because it's not about the angles that matter, it's about the length since it's smaller. So
Okay.
the angles won't match the bigger triangle.
Angles will match. Angles have to match. That is a precondition for being similar, okay? So angles have to match, no question about it. I'm talking about the sides. Yeah, let's see if somebody has. Yes, Anvi.
The sides won't match because they're both different sizes.
They will not match, but I need a mathematical formula. So when you talk about a property of a shape, there is a way to represent that. Yes, Amoga. Let's see if you have the answer.
What does that, on the top triangle, what is that a P?
Yeah, PQRSTU.
Are you asking for the formula?
Yeah, I'm just trying to ask. See, in this case, when I said these two triangles are congruent, so I said this side is equal to this side, this side
okay.
equal to this side. So I want to see if you guys are aware of any relationship between these two triangles.
So
Similar way.
P and G.
PQ. This is Q.
Oh, P and Q, yeah. Okay, that's
P-
a Q. Oh, PQ is equal with ST, like
Equal to-
similar to ST.
No. So here, yeah. Let's see if Vishal or Vivun have the answer. Otherwise, I have the answer any which way. Yeah,
Are
Vivun.
they proportional?
They are proportional. Vishal, what was your answer?
I was about to say about proportion because I remember your other class. And if PQ is not equal to ST,
They are not equal to. So this is the, see, I was kind of wasting everybody's time here, right? I took last 30 minutes to get you guys to this point where you will get this in your register in your mind that when I'm talking about congruence, I see the sides being same. When I'm talking about similarity, the angles are only same and the sides are in the same proportion. Yes, Amoga?
I didn't mean to say they were equal. I meant to say like.
They are in the same proportion, yeah.
Yeah.
Yeah. So now there is a formula that comes out of it, and that is PQ divided by ST. This side and this side. And again, how you decide that? Meaning the sides opposite to the matching angle. See, when I said that when the triangles are similar, meaning this angle is equal to this angle, and this is angle 2, this is equal to angle 2, this is angle 3, this is equal to angle 3. So sides are in the same proportion, meaning the sides opposite to the matching angle. So this angle and this angle are matching, right? So the side opposite to that. So let's take the first one. Side opposite to angle 1 is what? QR. QR divided by side, this is the matching angle, right? So QR divided by TU. Now let's take the second one, and angle 2. What is the side opposite to that? PQ. PQ divided by the matching angle is this one. Side opposite to that will be ST. Will be equal to, let's take the third angle. Third angle is this one. Side opposite to that is PR divided by, what is the matching angle? This one. Side opposite to that is SU. So only thing that you have to keep in mind is two parts. When I'm talking about similarity, only the angles are same between the two shapes, except for the case when it's a circle. Okay, circle is just zoom in, zoom out. You don't have angles. Except for a circle, every other shape which has corners or angles. So when we talk about similarity, only the angles are same. When we talk about congruence, then they are exactly the same. So remember this thing, same and similar. They are not matching, okay? They are not the same and similar, not the same. Yeah. So same is congruence, similar is similar. When you're talking about same thing, every side is equal, this side is equal to the corresponding side, this side is equal to the corresponding side, this side is. And again, when you say comparing, you will always go by the matching angle, the side opposite to the matching angle. Advik, you can sit properly, beta. I can see your knees. Yeah. So here, when you see the triangles which are congruent, you will always look at the side opposite to the matching angles. Okay. So if these two angles are matching, you will always look at the side opposite to that. So same way, when you talk about similar triangles also, here only the angles are matching, and this is what you get. So it says when the triangles are similar, the sides are in the same proportion. And this might hold true. This This will hold true for every shape. Every other shape. I mean, everybody talks about similarity with respect to a triangle. I made it generic for you guys. Every shape that you pick up, the sides will be in the same proportion. If you look at, let's say, a trapezoid. Zoom out. Zoom in. So you have, see, when they are similar, meaning if this is angle 1, this is angle 1, this is angle 1. This is angle 2, this is angle 2, this is angle 2. This is angle 3, this is angle 3, this is angle 3. This is angle 4, this is angle 4, this is angle 4. So when you're talking about similar stuff, you're actually talking about zooming in, zooming out. Meaning the corners, the angles of the corners, they don't change. Only they get expanded. So here, when you talk about this one, here also, the sides will be in the same proportion. Meaning, you pick up, let's say, between this one and this one, these two if you're talking about. So, this angle and this angle are matching. What you will do, side opposite to angle 1 is this one. This one divided by, this is the matching angle, side opposite to this one. You pick the second matching angle and the side opposite to that. So that is how you can say when the things are similar, the sides will be in the same proportion. And if any of you don't remember, who has been part of my class where I have tried proving the Pythagorean theorem, this is the basis of that, if you remember it. Yep, Yadvik.
Oh wait, so zoom in means bigger and zoom out means smaller?
Yep, you go inside, you become big, right? If you're looking at Earth, let's say from the space, if you go further up, Earth becomes smaller. You're zooming out, moving away. When you're zooming in, getting closer, it gets bigger. Yep. Yep. Yeah, Tanu.
Nothing, sir.
Okay. But is this clear to you guys so far?
Yeah.
Yes, sir.
Okay. So,
Yes, sir.
so remember this. When you're talking about similarity, you're talking about zoom in, zoom out, and this ratio. And when you're talking about ratio, be careful. There are two things that you have to take into account. One is you're talking about the sides opposite to the matching angles. When you're saying these two triangles are similar, look at which are the angles which are matching. You cannot pick this angle and this angle, and then take the opposite side. That is the first caution. And second thing is, your numerator or denominator has to be from the same circle, same shape. Let's say when you're putting the proportion, you are picking QR. QR is this one, meaning the bigger triangle. And denominator you are putting as TU, which is a smaller triangle. Make sure the next ratio also, you are picking the side of the bigger triangle, the numerator, and side of the smaller triangle, the denominator. You flip this, you'll have fun. Yeah? So two things. Remember the sides when you talk about, sides are with respect to the angle which is matching. Okay? In the ratio. And then your numerator and denominator should be from the same shape. Okay? Don't flip it. Saying the first ratio you pick this one versus this one, second ratio even you pick the right angle, but you flipped it, meaning you put the side in the numerator. So what I'm going to say is 2 by 4 is not equal to 4 by 2, okay? These two are not same. You flip it, you'll have fun. Okay? Alright. So this is on the similarity. Any questions so far? Anybody and everybody, please confirm. If you have any doubt, any legitimate doubt, let me know. Alright. Now, shall we go to the next one, next topic? Okay. So, next topic is associations. What do we mean by association of data? Somebody with EX.
Yeah, it's me, sir.
It's you, okay. So Vivan is a surprise element in the class, huh? Okay, alright. So, what do you mean by association? And again, you guys will get tired of me soon because I do that on purpose. Meaning, I will not jump to any mathematical formula discussion unless we understand the concept, okay? So I'll make sure that I'm wasting your time for initial 5-10 minutes, enforcing or emphasizing the fact that it has to be relatable stuff. Similarity is so very similar, so much related to the playing that we do on the phone or gadgets or any iPad for that matter. Even I've seen 6-month-old kids, they keep zooming in, zooming out. They might not know the similarity, but we should be able to relate that. Yes, Dikshita.
Can you give us like an example about like similarity with numbers?
Similarity with numbers? Okay. Let's look at this. This is a square. Okay? Every side is 5 centimeters. This is a square. Every side is 5 centimeters. I zoomed out. moved away from the square. This square looks like a baby square. Now every side is 1 centimeter. So what do you see here? All the 4 angles are 90 degrees here. Here also is the same. Only thing changed was sides became smaller. Yes, Vivan.
So any square ever is like any square ever like if it, like two different squares are similar.
Any two different squares will be similar. But that will not be a generic statement. This rectangle and this rectangle versus this rectangle may not be similar.
No, I'm talking about like square specific.
So for square and circles and equilateral triangles, you can assume that they will be similar.
Wouldn't that also apply to like a rhombus?
Yes, it will. Or it may not. It may not. Because you can have a rhombus like this, or you can have a rhombus like this. What I'm trying to say is, if you have squeezed the rhombus way too much, it has become much thinner, then a miniature of this rhombus would not be similar to the miniature of this rhombus. Make sense? Yeah, I see Vivan in 2 places. In one place I can see his picture, one place I cannot. Okay, any other questions? No? So, Dikshita, you got your answer, right? How do you see the numbers part of it?
Yes, sir.
Now, we are coming back to the next topic, which is associations. Associations in data. What do we mean by association? If you guys know the literal meaning of it, then it'll be easy. Yep. Yep, Pranav.
Isn't like the other one where like the rhombus is squeezed too much is a kite?
No. Squeezing a rhombus will never become a kite. Because rhombus has all 4 sides. Just the squeezing it will change the angles. But kite is different. It doesn't have all 4 equal sides. Okay? Only 2 sides here and 2 sides here are same. Yeah?
Yes, sir.
Okay. Now, switching topic. So I can only see Bhupal's hair. Bhupal. Yeah.
What's that?
Yeah. No, I'll keep waking you guys up.
Always like
No. Okay. Now coming back to the next topic, which is association in data. Now you guys have to tell me what is association. You guys are studying in an English medium school. I have studied in a Hindi medium school. Tell me what is the meaning of association. Association. Yeah, Vishal.
Is it something that's like similar in relationship? Like if between 2 variables, like if one thing changes, it changes the same way? Like a proportional relationship?
You have gone a little too far. I'm just asking what is the meaning of association in plain and simple English. Okay, let's see how much English you guys can teach me. Yeah, Bhupal.
So association, like it's like wait, I just forgot. Wait. Like a connection.
No, I'll not take it. Dikshita, let's see. You guys actually think too much, okay? Keep it simple. Yeah, Dikshita, tell me.
Is it like a meeting?
Yeah, association. Boys association. Yeah, Amoga. Tell me.
Is it like it's like a relationship between like 2 variables?
No, that's what I was saying. You guys probably think too much. Maybe.
It's like
Yeah, Vishal, you're saying something.
Maybe a statistical relationship?
Okay, don't go that far. Okay, I'll stop you guys on purpose. Okay. So let's look at the English part of it. Association. Yeah, Moga.
Is it like a connection?
No, a group. Associations. What do you mean by association? Everybody knows, boys association, girls association, welfare association, child care association, whatnot, right? So whenever you say association, you are essentially talking about a group where you have a lot of people, a lot of things together, right? Do you guys agree? Yeah. So when you say associations in data, we are talking about, hey everyone, don't do that. Class is not over yet. So I will allow those entertainments only towards the end of the class, when we have just 2 more minutes and when we are about to say bye. But no more entertainment in between. Alright, so associations in data, meaning when you have a lot of data, you are putting them together. Now, who all remembers what is a scatter plot? Yep, Advik, tell me, what is scatter plot?
Like a dot plot?
Scatter plot. Yeah, like a dot plot. Yeah, Amoga, any other?
Scatter plot. Oh, scatter plot. Is that where you like put different information and there's no big type of order? It's just like they all go in a specific line?
Okay. That is one answer. Amoga, your
It's
answer.
like a graph which like it uses like dots to like show values.
Lot of data. So, yeah, one last answer. Vishal, you're saying same thing?
I think it's the data of showing dots and showing variability.
Yeah. So, I would not say variability, but yeah, when you say scatter plots, it's a lot of scattered data, lot of information. Or now you can relate it with the word association of data. So when you look at, let's say, if I talk about, this is my math score on this 10, 20, 30, 40. So there was a test for math and science that happened in one grade for 50 kids or 20 kids. So on the horizontal axis I am putting math score, and on the vertical axis I am putting, let's say, science score. Okay, so 10, 20, 30, 40, 50. Let's say it was a 50 marks exam. So let's say there were 20 kids who appeared for it. One child got 20 in math, 30 in science. So this represents the first child. One other child got 22 in math and 28 in science. This becomes my second. Third child got 30 in math but 20 in science. So this is the third one. Similarly, let's say if we plot every point for child scoring math and science score, based on how much score he or she got in that test in math and science respectively, and plot it on a two-dimensional coordinate plane.
Oh,
This becomes nothing but your scatter plot. Yeah? Can you guys relate to it? And again, let me state it one more time. I'm just trying to plot the scores obtained by 20 kids in a class when there was a test happened for math and science. It was a 50 marks test. Math is on the horizontal axis, science is on the vertical axis, and every point represents the score obtained by one child in math and science. So X is math, Y is science. Yep. Yeah, Advik, you had a question?
They look like a bunch of tadpole eggs.
Yeah, same thing. Yeah. Yeah. Vivan, you had a question too?
I was gonna say I feel bad for all of those kids.
Yeah. No, see, when you have a bad teacher like me, you can get less score. You don't have a choice. So yeah. So anyways, so this is just the data representation part of it. See, data is not for me feeling bad. Okay? Data is for deriving interpretation out of it. All the different types of charts, graphs, plots that we'll come across, trust me, we don't have to feel bad about it. These are the scenarios or the collection of data that will be used by different people to derive interpretation out of it. Now let's say this class did this bad. Okay? Everybody got a bad score. What is this telling? This is telling that either the kids were not prepared or it was not taught well by the teacher. So kids will be, hold it. So kids will be given the assignment or a clear message to study well, or else they might have to repeat the same grade one more time. Or if it was a mistake by the teacher, either the teacher will be fired or will be given a very strong message that you are not paying attention to what you are paid for. Do a better job next time. Next time when we have a scatter plot like this, you'll be scattered all over the place. Yeah? So now look at the message here. This data gives, when the principal looks at it, principal can understand what is going wrong in the school. Are the teachers bad or are the students bad? And then they can derive an action out of it. So data is not for getting emotional. Data is enabling you to make informed decision. And imagine a scenario when this class had 500 students and there was no scatter plot like this. If the principal of the school had to go through the marks for all the 500 students, one by one, that would have been a nightmare. And after going through all 500 records, how informed the principal would have been, unless he is a supercomputer and he is super intelligent. No interpretation he or she can derive from looking at the raw data. This gives you a trend, a view into it. How the class is performing. If you are looking at reading 50 records one by one, math 20, science 35, math 16, science 42, okay, third student, math 49, science 22. After he reads through all the 500 lines, he'll forget what was there in the first line in the first place. And then there is no question of getting any interpretation out of that whole reading exercise, or tiring reading exercise for that matter. Okay? So a scatter plot like this gives you that view. And there are different means of doing it. We'll learn about the bar chart, pie chart, the histogram, whatnot. Okay? But here in this scatter plot, now you relate this with the first statement that I was making. Associations in data. What do you see? Lot of data. A group of data. Association of boys. Associations in data. Yeah? Girls association. Data association. Right? Now you can relate. Yeah? Are you guys with me so far?
Yes, sir.
Now, what do you mean by positive association versus negative association? Now comes the $1 million question. Nobody gets $1 million though. Do you know what is a positive association?
Where like the class is passing and like the negative association is where like the class is failing.
You are getting closer to it. Okay, let's see what are the other options. Yadvik.
Can you repeat the question again?
What is positive? See, we all saw after my 20 minutes of blabber what is an association in data. Now my question is, do you know what is a positive association versus what is a negative association? Okay, again you have to relate and say. Okay, Bivon had raised his hand. Let's see if Bivon has to say something. Then I'll go to Bivon and Advik.
Is it like for positive association? Is it like if math gets better, like if it gets better, and then science gets better, and negative is like one of them goes down and then one of them.
You are thinking in the right direction, but little far. Okay, let's see what Vishal has to say. Yeah, Vishal, you're saying something.
Positive association is like an increase of the value, and like negative association is like the decrease.
Still close, but okay. Let's hear Vivan, and then I will say those magical words. Yeah, Vivan, you have raised your hand.
I think positive is like when they're like both above like a certain number, and then negative is like when they're both like below a certain number.
Close, but not close enough. Let's see what Dikshita has to say.
Is it like positive mean like you get like a big number and negative means like small number?
No, I think. Okay, how do I see Dikshita in two places? Dikshita paired with Vasundhara, Dikshita paired with, okay, interesting. Anyways, so let's look at this now, okay? Now, I said associations in data. So data, association of data. I have a lot of data. And remember one thing, if you're talking about any kind of a graph chart or any plot like this, trust me, it is done with some amount of effort. And there is a reason for the effort. Because somebody is trying to derive some interpretation from that. Now, let's say Vivan was feeling bad about the class. Now, I will put those points. Now, these are the 20 points for the class. Vivan, do you feel better now? Is anybody feeling better by seeing this one? Yeah?
Yeah.
So what do you see here? Without going into the double click of the data, without looking at each and every exact element of data, what you see here is there is an increasing trend. There is a positive trend. Very few kids got less, but there is an upward trend. Yeah? Yeah, somebody is raising hand. Somebody is trying to say something. Who is that? Nobody? I see somebody with name Susmita.
That's me, Lakshita.
Lakshita, okay. That's why I was wondering. I have surprises in my class. Okay. So, yeah. So, now here what you see, there's a positive trend. Vivan, who was feeling bad by seeing the data before, he was feeling bad for the class, now he's feeling better. Because just by looking at the graph, it gives a very, very positive message that yeah, this is going upward. There is a positive trend. That is what is called positive association. Meaning, there are a lot of kids who have got very good score. There is a positive sign. That's why it's called positive association. Imagine if I had plotted the same data for 20 students or 40 students, and then that would have resulted into something like this. Going down. Negative association. Pranav will start again. Yeah? Because what you see here is this. Look at this particular bracket. There are kids who are doing very good in maths, but literally failing in science. Yeah? If I had association like this, going in this direction, if you look at this segment, what do you see? A lot of kids are scoring very good in science and math both. If you look at this, one subject they are scoring well, but they are failing in science, maths, in science. So, just by looking at this data, without going into each and every data element, you can figure out what is the behavior, what is the trend. So if the trend is going downward, there is a problem. Science teacher will get fired. If the trend is positive, both the teacher, math and science, both the teacher can say, I have done a good job. See, some serious students have got a near perfect score in science and math both. So the job of the science and math, both the teachers is safe. Yeah, everyone.
Like me.
Yep. Like you. Yep. So that's what I'm saying. So every graph, every plot, every chart that you come across, trust me, that is meant with a purpose. If anybody had to read through how many people were infected with COVID in Texas alone, in Dallas alone, forget about Texas, during those COVID days, it would have been a nightmare to figure it out. But every day we used to see the chart that used to give a very good view of city level, state level, country level, or even continent level view without spending too much time. So that is the beauty of data. When you plot, use the data, organize that, plot that in some form, it gives you some intuitive view out of it, and you can use that for making a decision. Or kind of getting a conclusive view of how do you read the data. Yeah? Yes, Dikshita.
So that data is considered as like stato.
What is that? Statistics?
Is that data considered like as a stato plot?
That this name of this diagram is called scatter plot, right? So in this scatter plot, if you have data giving you a downward trend, that is called negative association. If it gives you an upward trend, that is called a positive association. Yeah? And when we go to scatter plot in detail, and again then we'll probably double click on each and every property of it, what is called the line of influence and other stuff. But as far as the negative and positive association is concerned, association data, this is what it means. Association of data, you can talk about when you have a lot of data element, and then the relationship among them in showing a downward trend or upward trend defines whether it's a positive association or negative association. Does that make sense?
Yes, sir.
Everybody clear?
Yes, sir.
Yes.
Yes, sir.
Okay. So